Hey class, what's going on? I'm actually going to be here teaching you about a little bit about free body diagrams. I know they are tough, but I want to do some ones that are just like similar to what we've had in the past and stuff that we're going to be doing in the future. So, basic one is, let's say we have a box sitting on a table, and we have a velocity pointing to the right. It is constant. All right, it's a constant velocity. All right, now, so that means that, let's say there's a force applied this way. Okay, so the free body diagram would look something like this. You have a dot, you have force of gravity going down, you have force normal going up, you have force applied, and then there is also force of friction. Now, since it's traveling at a constant velocity, Fa is equal to Ff, and Fg is equal to Fn. All right, so Fa is the force applied, Ff is force of friction, Fg is force of gravity, that's mass times gravity, all right, and Fn is normal force. All right, so those would all be equal to each other. Okay. All right, let's go over another example. Let's say we have a wall. Now, a lot of times you draw lines like this, kind of indicating a wall. That's not done. That's terrible. That's terrible. So let's see, we have lines drawn like this to indicate that this is some sort of solid, rigid structure. All right, and let's say that we have a book being pressed against this wall by someone. So there's some force applied pressing this book against the wall, right? So the book is stationary. It's not moving. So the free body diagram would look like this. You would have force applied to the right. Now this time force normal is pointing perpendicularly away from the wall, which is to the left. You would have force of gravity. All right, so you have force normal pointing left, force applied pointing right. They are equal. Then you have force of gravity pointing down, force of gravity pointing down, and then up would be force of friction parallel to the surface. So force of friction is always parallel to the surface. Normal force is always perpendicular to the surface. Those are two things that are common themes throughout this unit. All right. So if you were to decrease the force applied, what might start happening is the box might start to slide downwards. So if you were to decrease the force applied, it might start to slide down, and therefore friction would be up. And then you'd have the force of friction up. So that's why the friction is like there, because if it were to slide down, it would slide down, making friction point upwards. Hopefully that makes sense. All right, so in this case, we have circled in blue. Those two values are the same. Circled in red, those two values are the same. Now they're pointing in opposite directions, but their numbers are the same. All right, same thing goes with Fn and Fa, Ff and Fg. Those would be all equal to each other. All right. All right, we're going to do one more example. All right, so let's say we have, let's do a wall, some sort of roof, or rigid roof. All right, and let's say that we have a tension here, a tension here. All right, we have a tension. So these tensions right here. This is force of tension, okay? This has mass, that's mass, all right? And then that's it. All right, so it's just some object. It's being hung by these two strings at an angle, right? They're not perfectly up and down, they're at an angle, all right? And they both have their own tension. So the free body diagram would look like this. You'd have force of gravity here, and you would have tension here of one of them, tension here of the other one, and that's it. All right? So that's Ft and Ft. All right? Now, of course, they're at an angle, so therefore, Ft over here has an x component and a y component. Fty. Same thing goes with this one. This has a x component and a y component. All right? So, things that are equal. All right? So, circled in green. Ftx equals Ftx. Those two Ftx's are the same. All right? Now, circled in black, all right, we're going to have Fty plus Fty is going to equal to Fg, right? These two y forces are going to add up because they're both pointing up. They're both pointing up, and they equal to that Fg. All right, so if you were trying to figure out the x and y components, so you would have, oh, whoops, I didn't know I could do that. If you could have x, right, in the x direction, you would have Ftx equals Ftx, like that. And for y, it would be Fty plus Fty equals Fg. All right? You can include the absolute value signs if you want. All that does is ensure that they're both positive because they are technically they're in opposite directions. So some are positive, some are negative, but in essence, their numerical values are the same. All right? Hopefully that makes sense too. Thanks, guys.